Okay, so this was the inverse line of reflection we said was because these points are all equal distance from each other. Whenever you graph the reflection, they're equal distance from this line. And every single point on here shares the same x and y value. That's why it's called y equals x. So when you interchange your y with your x, it reflects over this line. All right, so what we're going to do on the bottom piece lastly is graphing. We have f of x equals 2x minus 3. Is this original or is this the inverse?
Original.
Why?
Because it doesn't have the negative one.
Yeah, it doesn't have a little -1 notation at the top. And then I also provided you the inverse above. F inverse of x would be 1/2 x plus 3. So yes, you can go in your calculator and get all these table values. But you could also find these values by just plugging in numbers. You plug in an input, you get an output, which is exactly what the computer is programmed to do. So let's start with -2. If you use your calculator, you can plug it in. 2 times -2 is -4 minus 3. -1. 2 times -1
-2.
minus 3.
-5.
2 times 0
0.
minus 3.
-3.
2 times 1
2.
minus 3.
-1.
2 times 2 minus 3. 2 times 3 minus 3.
It's just going up by 2.
And 2 times 4
5.
minus 3.
It's 5.
2 times 4 is 8 minus 3.
5.
Okay, so James said they're going up by 2. Why are they going up by 2?
We don't know.
Oh, because it's linear and your slope is 2. So we know if it's a linear function, we're going to have a straight line. Okay, without doing all that, could you anticipate what these coordinates would be right away?
Yes. -7.
You just flip them because it's the inverse. So we know that the inputs and outputs will get reversed with each other. But let's go ahead and graph this first before we even do that, so we don't get confused. -2, -7, way down here. -1, -5. 0, -3, which just by graphing those 3, I see the slope. I know it's linear, so I'm going to continue using my slope. Up 2 over 1. Do all functions have that slope? No, only linear does. Only linear is constant rate. All the other ones, you cannot use that. So this was f of x, the original. Now we want to know what the inverse function would be. So the inverse we know is going to reflect the input and outputs, which means my outputs become my inputs and my inputs become my outputs. So we get -7, -2, -5, -1, -3, 0, -1, 1, 1, 2, 3, 3. Why did that one stay the same? So where is that point going to lie at? I'll give you a hint. X and Y are the same. They're going to lie on the reflection line, the y equals x. And it's going to cross because they share the same coordinate. All right, so go graph the inverse. We got -7, -2, -5, -1, -3, 0, -1, 1. Okay, brownie points. Can anybody tell me what else is inverted? Just by looking at the way I'm graphing right now. Other than the coordinates, what else got inverted right now?
The line.
Nope, nobody got it. I'll give you a hint. This one went up 2 over 1. This one goes... Oh. So those characteristics of when we think of inverse also matches up when we think of slope and intercepts and all that stuff. They will all be backwards of each other. All right, so do you see the reflection over y equals x? Are they all equal distance?
Yeah.
There's y equals x. So yep, it is a mirror image on both sides. Your y's became your x's and your x's became your y's. All right, so now I provided you the equations. Well, we're going to use algebra to find them on our own. That was all review. We've done this in first semester. So now let's get to second semester. How do we find inverse functions algebraically? Okay, so first of all, do we even know, I like how we read the first one, it says change the function notation f of x to y. Does anybody know what f of x means? Why do we call that function notation? And yes, I've shown you a long time ago. Huh? Well, I'll give you a hint. It starts with blank notation. What does it say?
Function.
Does y have anything that represents function?
So it's a function of x.
Exactly. It's a function. What does function mean? It passes the blank line test. I've heard it. A function is something that passes the blank line test. Y'all are the first class today. That's a shame. Y'all have heard this since 8th grade.
Multiply.
Okay, let me draw a sketch then. Can anybody tell me which of these is a function and why?
What? Oh.
Which of these graphs is a function?
You.
This one?
Yeah.
Why?
I don't know. Because it looks like a graph.
Oh, there you go. So she says it only touches each point once. What only touches it?
The line. The function.
The vertical line test. What the vertical line test means is as you move your x's, you only have how many y's?
One.
1. But on the circle, if as I move my x's, do I only have one y right here for this x? No, you have two different y's. So a function means for every x value, you get only one y value. It passes that vertical line test. So we would model this with f of x, meaning this is a function. We are calling it a function. F of x is still the same thing as saying it's your output. It's my y value. Over here, I wouldn't put f of x because it is not a function. So you don't call it a function. Instead, you just say y equals. Meaning, yes, you get outputs, but it won't be a function. It would be just something like that, where you could get more than one output. Okay, but are they any different? Is f of x still modeling an output? If you plug in something, you get something out? Yes.
Y.
And y is also the same thing as an output. So the reason why here I said change function notation f of x to y is because when we're doing solving with algebra skills, it makes more sense to have y's and x's. If you have an f of x inside the equation and I say solve this for something, it throws you off. So the first thing I want you to do is switch this f of x and make it a y, just for solving reasons. That was step 1. We rewrote it and just called it y instead of a function. Okay, step 2, what does it say? A little bit louder. Step 2. Okay, I gotta make everybody read it since y'all are all shy, okay? Step 2, reflect the... We'll do it again. Step 2 says reflect the...
X and Y using the function.
Reflect the... Okay, why do you think we're reflecting the x and y values? Because what am I trying to find right now? An inverse what? Function. And we know inverse functions means that we're interchanging our inputs with outputs. So what am I interchanging? My x with my y. Does that mean do the opposite of what you see? No, it just means switch x and y. So rewrite this for me. I want the inverse equation. So switch the y. What does y become? X. And what does x become? There you go. So technically speaking, you found the inverse equation right now. However, can you graph this? Is this in terms of I plug in an x and I get a y? No, because y is not by itself. Right now, y is not being represented as an output. So even though this is the equation, we're going to solve for y to make it proper, to make it look like the usual input-output scenario. So let's get y by itself. Step 3. What do I need to do? Cover up the opposite side and divide by 2. There we go. We got y by itself. We got y equals x over 2, right? But how do we tell the reader that this was the inverse I found? Well, step 4 says make sure you change that y to
Y negative 1.
f inverse of x. But if it wasn't a function, how would I write it? Y inverse. See what I'm saying? So if it's a function, you put the negative 1. If it's not a function, you leave it as y. So we're going to rewrite this. Was it a function? So we're going to put f inverse of x equals x over 2. You found the inverse. Was that horrible? Why?
How do you know if it's a function?
So let's put it in our calculator. I know it's a function because that's a linear line right here. If I put it in my calculator, we got 2x and we have x over 2, right? That's the original. This is the new one. First of all, do you see the reflection taking place? Yes. Second of all, are they both functions? Why? Because for every x, it has one y. If I go along the vertical line test, they both pass it. So yes, you can model it as a function. All right, let's do 2. First step, change function notation to y, just to make it easier on you. Second, we want to find the inverse. How do I find the inverse? We reflect the x and y values. So then this becomes, that's for you to fill in.
7y.
What's over here?
Oh, x equals 7y.
There we go. And then step 3 says, okay, we'll solve for y to make this a proper equation. So then I'm going to cover up the opposite side of my equation where the y is. I cover up the x side. Furthest thing from y is the subtract 1. We get x minus 1. I'm going to run out of room. Equals 7y. Again, cover up the opposite side of the y. Last step, divide everything by 7. Okay, so then step 4 says, okay, well, we solved for y. Do you guys think that this is a function or not a function? Very easy. Plug in your calculator, see if it's a function.
I was gonna say no.
Yeah, I think it's no.
I'm gonna make an educated guess. Say no.
I don't want your educated guess.
Oh, I plugged it in.
Okay.
It's not a function.
Okay, well, you're wrong.
It is. How do I plug it in?
You put it- you want why you put it in the other one?
Okay, well, let's put it in. Numerator, x minus 1 divided by 7.
Oh,
There you go. Is that a function?
No.
Sure is. It's a straight line, guys. That is a function. So you have f inverse of x equals x minus 1 over 7. Okay, so I know I haven't shown you this yet, but do you guys know how to solve equations that deal with radicals? I don't know what that answer means. Can y'all explain what that means? All I hear is silence. I guess I'll ask again, just in case you didn't hear me. Do you know how to solve equations that have radicals in them?
yes.
Oh, okay. Because that was literally our bell ringer this morning, wasn't it? Just say it. Okay, so you do know how to solve it. Well, now you're doing the exact same thing, but I'm asking you to find an inverse function. I'm not asking you to solve for x. I'm asking you to find an inverse function. It still deals with solving. You're still going to have to get rid of radicals. But I want to find the inverse. So I want to give you guys some time to try out 3 before I give you how to do it. Try out 3, doing the same thing we just did and using your knowledge of how to solve things with radicals. Which means try it. Gauge. Oh, I see your pencil. Julie. Foley. Good. Except your function notation, fix that. Right now it just says f inverse, but when you have function notation, it's f inverse of x. It's a function of x values. Does that make sense?
Oh, okay, I forgot.
You forgot the parentheses with the x. No.
That's, I know.
Okay, do we need more time?
What are we supposed to get? Is this
I don't know.
Okay.
Did you do it?
Yeah.
What'd you get?
First what I did was,
I don't want to get out the answer.
I don't know if it's right or wrong.
Yeah.
Yeah.
Okay, so let's follow the same 3 steps, guys.
Forgot how I did it.
Same ones. So, first off, make it easier for algebra's sake. Make the f of x a y. Okay, and then second of all, we're finding an inverse function, which means we need to write the inverse. How do I write the inverse? How do I write the inverse? Flip what? X and y. So then I get
3. Cube. Yeah. And then there you go.
y plus 8. Okay, and then step 3, solve for y to make it a proper equation. So I cover up the opposite side of the y. Can I get rid of that 8? No, because it's stuck inside the radical. So this is a cube root radical. How do I get rid of a cube root?
Cube it.
Cube it. So I cube this side. I also cube the x. Cube root goes away, and we get
X cubed.
equals.
Y.
Good. Okay, now we got one more step left. I cover up the x cubes. How to get rid of the plus 8?
Minus.
There you go. You got y by itself. And if you were to put this in your calculator, are cubics functions? Just put it in there. See what it looks like. Does that look like a function? Or does it look like something that's going to come back around? It's a function. All right. So then we put f inverse of x equals x cubed minus 8. Okay, so I'm actually going to do number 4 with you guys. So do you remember when we were solving these equations, you ended up having something like this, where I said, oh, we need to expand this out and multiply it by itself in order to get x outside parentheses? This was because we were solving an equation for x, right? We were trying to get x by itself, and you can't get x by itself if it's in parentheses. That's the only reason we had to do this. Keep that in mind for right now. Again, we only had to do this because we were trying to solve for x, and we needed to get it out of those parentheses. Keep that in mind. Now let's do the inverse of this. F of x, we're going to change to y. Step 2, write the inverse. What's the inverse? Okay, and then step 3, solve for y. To make it proper, I cover up the x, the left side. Furthest thing from the y is the 2 because it's outside the radical. Get rid of that. Subtract the 2, subtract the 2. We get x minus 2 equals square root y minus 4. Can I add 4 to both sides? No, because it's trapped under the radical, so I got to get rid of that radical symbol. Well, this is what type of radical? A square root, which means I need to raise it to the 2.
Would you do the same?
So here we go, squared it. So I get x minus 2 squared equals y minus 4. Now look at your paper. Is there a reason for me to expand this out and multiply x minus 2 by itself? Is there a reason to get x outside the parentheses?
Actually, no.
Why not?
Can you solve for y?
Thank you. We're not solving for x. We don't care about the x value. So if you're going to sit there and expand this out, you're just making it more difficult when all you have to do now is add 4. Can I add 4 to that 2? No, it stays outside, just like how you see it. So those of you that are wanting to multiply that out, that's only if you're solving for x, where you need to get x out of the parentheses. We don't need to do that. We're getting y by itself. So then our inverse, I'll give you guys a shortcut. It will be a function, so we'll have f inverse of x equals what? What's on the left side? Parentheses x minus 2 being squared, and then what do we do to that? We added 4. There you go. Question there? Not bad, right? Okay, we're going to go ahead and skip number 5 and finish off with this bottom one, and then we'll call it a day.
Wait, are you gonna finish it off?
Why are we skipping 5?
Because I'm not going to have enough room.
Oh.
Is it finished?
It's so simple.
I mean, we can do it if you want.
No.
Because then you gotta like.
You would square root instead of square.
I would say number 6 looks more difficult.
Yeah, 6 is what we're going to focus on because we've been focusing on square roots and cube roots, so that's what I want to kind of go back to. All right, so number 6, we change f of x to y, and I want the inverse. Okay, so then I write it as how? Inverse then. X equals, and the minus 1 on the outside. Okay, make it proper by solving for y. So I cover up the x. Got to get rid of the outside values. We add the third and the minus 1. This one's furthest away. It's not attached, so add 1, rewrite. Okay, now don't freak out because we have a fraction. I taught you guys how to get rid of a fraction very easily. Is it a good thing to divide by a fraction? No. We can multiply a fraction by its reciprocal, yeah. So if I want to cancel out 1/3, remember off to the side how I'd show you guys? Well, here I got 1/3. If I multiply it by 3/1, well, 3 divided by 3 goes away. 1 divided by 1 goes away, right? So if I want to get rid of 1/3, I'm going to multiply it all by 3/1, which means if I do that to the right side, I'm going to do the same thing to the left side. Questions right now on how I got rid of the 1/3. Okay, let's write it out. 3 times x is 3 times 1 is 3 equals square root y plus 9. Only 2 more steps and then we're done. Okay, I cover up the left side. Can I subtract 9?
Square it.
No, we got to square it. We got to get rid of that radical. So I square it, square all of this, cancels that out. Bring down the y plus 9. And last step. Subtract the 9 from both sides. Okay, so we got y by itself. This will also be a function, so we're going to write f inverse of x equals, what did we have? There we go. Done. All right, go ahead and start packing up.